The graphs of absolute value equations or functions also have a specific shape to them. So when you guys are trying to graph these, you know how to solve them, but when you graph them on a calculator or on Desmos or wherever it might be, the shape of them is shown below there. It almost looks like a V. It's going to be symmetric, so it should always be the same on the left and the right side of the vertex. But the function f of x or y equals absolute value of x is called an absolute value function. So that point you guys see at the bottom of the graph there, the highest or lowest point on the graph, which in this case would be right here, is called the vertex. And the axis of symmetry is a vertical line that divides the graph into two mirror images. That's why it's symmetric. So when we're looking at these graphs, the parent function is f of x equals absolute value of x. Once there starts to become number values that get thrown into the equation, the general equation for an absolute value is over here on the right-hand side. That one on the left is literally if nothing is being multiplied, added, or subtracted to that x value. So if something is being multiplied or added or subtracted to that x value, it's going to look like this. So we can tell a lot about what that graph is going to do, how it's going to move, how it's going to shift, just by understanding what this a value does to the graph. Now, a is going to be a number in your equation, but it can tell you a lot about what your graph's going to look like. So the first thing is it tells us whether it's going to stretch or compress. So if that a value, we don't care so much if it's negative or positive. So if the absolute value of that a value is smaller than 1, less than 1, your graph is going to be compressed, or we can even say squished, but the mathematical term is really compressed, but we'll say squished so you guys will kind of know what that means, and I'm going to show you here in a second. If the absolute value of that a number or value is larger than 1, your graph is going to be stretched or taller almost. So what does that mean to you guys? Well, compressed or squished means it's flatter or wider. So what that's going to look like is something like that. When it's stretched, and actually let me try to draw that just a little better. There we go. So then when it's stretched, it's almost like you're taking the ends and pulling on them or stretching them like you would a rubber band. So what happens is it looks kind of skinnier or taller. So that's what it means when it says stretched. So if your a value is smaller than 1, the absolute value, we don't care if it's negative or positive at this point, it's going to be compressed. If it's larger than 1, it's going to be stretched. So reflection means reflection over the x-axis. So if you have a positive a value, that's why we said we didn't care if it was positive or negative with the stretching and compressing. But if you have a positive a value, it's going to open your parabola or your absolute value up. If you have a negative a value, your absolute value is going to open down. And that's all you need to know. So right just from looking at it, you don't even have to graph it to know which way it's going to open. Positive, open up, negative, open down. So we talk about translations, and they're the horizontal and vertical shifts of your graph. So that's what the H and the K do. So the H is the horizontal shift of your graph. So that tells you the lefts and the rights. And when we look at an example, I'll sort of talk more about it. And then the K is the vertical shift of the graph. So that's your up and your down. So all of these things tell you what the shape of this graph is going to look like. Without even graphing it, you should be able to tell a couple of these things. So now let's go look at an example down here. So it says you guys can use Desmos to explore a little bit. I'm going to go through one example with you. If you guys look at B, not B, the graphs are A, B, and C. We're going to look at the middle one. It doesn't necessarily go with B. We're going to look at that second equation. So let's just look at the equation first. So it wants us to know what graph does it match with, what's the vertex, and then what's the axis of symmetry. Well, we're going to look at a couple things first here. If there is no k, we never write plus or minus 0, guys, but that is technically what the k value is. It's just that we're not going to waste the time to write it. You still need to know, though, that it's 0. So what this is telling us is that this is not going up or down at all. So we're going to just do or say that it's up 0. The 2 first tells us, because it's larger than 1, that it's stretched. Because it's positive, it opens up. And then the plus 4, or the minus 4, is your h. So here's the thing, guys. The actual parent function, general equation of absolute value is minus h. So it is minus whatever the h value is. So in this case, 4 is the h value, so this is going right 4. So what I need you guys to understand is that yes, it is minus 4, but the minus is part of the equation. So we almost ignore that minus, and the actual h value is positive 4. So what I want to show you, I'm going to have you guys try to finish it then, but on the third graph here, h equals -1, because this would originally be written as x minus -1. So the x and the minus are part of the equation. What is the h value? -1. But you guys know a minus, a negative to become plus. That's why they write it that way. So here, this would actually move your graph left 1. So just be careful with that. It is +1, but it actually is moving your graph to the left. Here, it's x minus 4, but it's really moving your graph to the right. So that right there, the right 4 and up 0, is your vertex. From the origin, that's where your graph is moving. If that's where your vertex is, you can look at the graphs a while if you want. 4, 0 is going to be graph A with your vertex right there. So your axis of symmetry is the imaginary line that goes through that vertex. So what x value is that line going through? Always the x value of the vertex. So if you guys find the vertex, you know the axis of symmetry. Always through that x value. So which graph does it match with? Graph A. So go ahead and match those other two graphs and see how you do with that.